So as part C of this 2.3, we will cover two problems which are applications of this work, application problem based on work that we just discussed. And then we will also cover what are the uses of this dot product. So let's take example 7 here. A wagon is pulled. A wagon is pulled a distance of 100 meters along a horizontal path by a constant force of 70 Newton. The handle of the wagon is held at an angle of 35 degrees above the horizontal. Angle is given, distance is given, force is given. Find the work done by the force. So, as shown in this figure, so the wagon is making an angle of 35 degrees to the direction of motion. It is pulled through a distance of 100 meters. So, absolute of D is given in the problem. The length of D is given in the problem, which is 100 meters. Then the force, length of force is given, which is given to be 70 Newton. Then the angle is also given, which is 35 degrees. So work done, if we use that formula, which is F dot T, work done by the force, is W, which is equal to F vector dot D vector, which is length of F times length of D times cosine of the angle between them. Length of the vector is 70 newtons and the distance is 100 meters, and then cosine of the angle between them is 35 degrees, cosine of 35. And this is going to give us approximately, if you compute, use your calculator and compute this, this is going to be approximately 5,734 Newton meter, but we know that Newton meter can be written as joule. So it is 5734, that many joules. So 1 Newton meter can be written as 1 joule. So that is what we are writing here. The next problem, a force is given by a vector F equal to 3i plus 4j plus 5k and moves a particle from point P with coordinates 2, 1, 0 to the point Q, which is 4, 6, 2. Find the work done. So we are given 2 points, so we can determine the vector connecting the 2 points. So displacement vector can be found out. So the displacement vector is the vector PQ, which is vector OQ minus vector OP, which is named the component form. If you write it's 4, 6, 2 minus 2, 1, 0. It will be 4 minus 2, 2, 6 minus 1, 5, 2 minus 0, which is 2. So this is vector D, the displacement vector. If you write this in IJK component, IJK form, you can write this as 2i plus 5j plus 2k. Vector f is also given in the problem. Vector f is given as 3i plus 4j plus 5k, which is 3i plus 4j plus 5k. So work done is f dot d, or work done in moving from the point, work done by the force in moving from P to Q is given by f dot d, which is the dot product of the two vectors here, this and this. The dot product is commutative, so the order does not matter here. So this is going to be equal to 3 times 2, which is 6, plus 4 times 5, which is 20, 5 times 2, which is 10. So it is 36. In case the unit of length was given as meters and force was given in newtons, then you would say that the work done is 36 newton meter or joules. But here the units are not given, so we can leave the answer the way it is. Now, what are some of the uses of this dot product? So how are dot products used for? The dot product can be used to find the angle between two vectors, correct? We can find the angle between two vectors. How? We know that if theta is the angle between the two vectors, then it is a dot b over length of a times the length of b. That's how we determine the angle. In particular, it can be used to determine whether the two vectors are perpendicular or orthogonal. Perpendicular or orthogonal. What does that mean? The two vectors are orthogonal if a dot b equal to 0. The dot product can be used to find the scalar projection and the vector projection. Scalar and vector projections of one vector onto the other. We know that the scalar projection is denoted by comp b onto a, and the vector projection is written as projection of b onto a. If a constant force moves an object, then the work done, if a constant force moves an object, then the work done is a dot product of the force and the displacement vector. So here we know that W equal to F dot D. So in the this is about the concept of this section 12.3. Then I have done from the suggested problems from the for the exercise, suggested problems from the exercise. I have done the problem number 5 is done in the video. Problem number 17 is done in the video. And then 23, 23, 20, 23, 35. All these problems are done in the video, 23 and 35, 23, 35, 41, 49. All these are done in the section videos for this particular section 12.3. So refer to the videos of this section. For the rest of the problems. There will be also the homework questions, so it will be very helpful to do the homework questions. So make sure to watch those videos from section 12.3.